You are welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
Hi guys, welcome to Scholar Online Maths. My name is Abiola Daniel. I'll be taking us to mathematics today, and here we have the topic indices. And as subtopic here we have laws of indices and application. Now we have different laws of indices, and researchers in mathematics have made us understand that we have five. Some said we have seven, and genius said we have even more than seven. But today we are going to break down the understanding to us that we have more, even more beyond seven, and which we are going to bring to understanding now. We have the first law of indices. The first law of indices here, you have a raised to power n times a raised to power n to give us a raised to power n plus n. Now you have a raised to power n multiplied by a raised to power n gives us a raised to power n plus n. Now this is a law of indices. But one thing you need to understand is that m is the power. N is likewise the power. That means you are having two identical numbers then of different power. For example, when you have 2 raised to power 2 times 2 raised to power 3. This law is telling us that we have 2 raised to power 2 plus 3. Then you have it to what? 2 raised to power 5 using the first law of indices. That means the first law of indices can only be used when you have similar number here. It could be any number of different power. At times it could be of the same power. For example, when you have 2 raised to power 4 times 2 raised to power 4, it gives us 2 raised to power 4 plus 4, which is 2 raised to power 8. Still applicable. Now, let us move on to the second law of indices. You have a raised to power n, then your big bracket times p is going to give us a raised to power m times p. Now this one is always applicable to when you have a number raised to the power of any given it could be a root, it could be square, it could be cube root, it could be raised to power 3 raised to power 4. Then you have it enclosed in a bracket, then raised to a power. You are going to have it to be in the number raised to the power of the product of the two powers. For example, when we have 2 raised to power 3 in an enclosed bracket raised to power 4, that simply means that you will have 2 raised to power 3 times 4, which is 2 raised to power 12. That's it. And that is how to apply this law here for a raised to power n times p. That is for the second law of indices. Now let us take the third law of indices. You have a raised to power n times b raised to power n times k. You have a raised to power n times b raised to power n times k. You have it in a bracket like this. Now, take a look at this. This is now going far beyond what we have earlier, but quite similar. Now, in this case, you have in our enclosed bracket, you have a raised to power n times b raised to power n. And then you have it here like this. Here is actually telling us to interpret this. You have it to be a raised to power m k times b raised to power n then k, which now looks similar to law number 2. That means you have it to be a raised to power m times k multiplied by b raised to power n times k. And these are to solve questions like this. For example, when we have 2 raised to power 3 times 3 raised to power 2 or raised to power 4, it could to give us something like this. Our a is 2, which is 2 raised to power 3 times 4 times 3 raised to the power 2 times 4. This is exactly what we are going to have. And that's how to apply the third law of indices. Now let us move on to the next law. Here we have a raised to the power n times b raised to the power n. Now here we have two different numbers and of different power, of the same power rather. Two numbers different of the same power. Tells us that we are going to have the result to be a times b raised to the power of n. That means when we have numbers like this, 2 raised to the power 4 times 3 raised to the power 4, we are going to have 2 times 3 raised to the power of 4. That is what the law is telling us. That we are going to have something like this. And that is for this law. Now let us move on to another law of indices. We have a times b in an enclosed bracket raised to the power n. A times b in an enclosed bracket raised to the power n. This actually is telling us that you're going to have a raised to the power n times b raised to the power n. For example, when you have 2 times 3 raised to the power 4, it's actually telling us that you have 2 raised to the power 4 times 3 raised to the power 4. That is what the law is telling us. Now, whenever we are solving and we come across things like this, we don't need to panic or use calculator. This is how to break them down. Now, let us move to another law. When we have a raised to the power n divided by a raised to the power n. No, ever since we have been solving with multiplication sign, but here we have something kind of different. We have a raised to the power n divided by a raised to the power n. You are now working with division sign. Here is telling us that we have the same thing we apply for the first law, raised to the power m minus n. The sign separating the two power will change to negative sign, which is minus. So we are going to have this. Let us take for example, when we have 2 raised to the power 3 divided by 2 raised to the power 2, we are going to have, according to this law, 2 raised to the power 3 minus 2, which is 2 raised to the power 1. That is how to apply this law. Now let us move to another law. We have a raised to the power 0. A raised to the power of 0. When we have something like this, a raised to the power 0, all we need to do is to say, according to the law, it says a raised to the power 0 equals 1. That means any number raised to the power 0 is equal to 1. For example, 2 raised to the power 0 equals 1, 5 raised to the power 0 equals 1, even 1000 raised to the power 0 is equals to 1. That is what the law is telling us. Even fractions, when you have 1 over 2 raised to the power 0 is equals to 1. That is what the law is telling us. Now let us move to another law. This law of indices states that a raised to the power minus n. When you have a raised to the power of minus n, now you now have the power to be a negative 1. It's telling us that you have 1 over a raised to the power n. 1 over a raised to the power n. For example, when we have 2 raised to the power of minus 2, it's telling us that you will have 1 over 2 raised to the power 2. Because this negative sign here is representing 1, then the over raised to 2 raised to the power 2. So we are going to have something like this. Now you have our a, it could be any number, then our n could be any number, but our n is what? Is the power. That means when you have 2 raised to the power minus 2, you are going to have 1 over 2 raised to the power 2. That's for the law. Now let us move on to another law. A raised to the power 1 over k. See, a raised to the power 1 over k. This is quite similar to the one we just saw, but here we are applying something else. This 1 over k is not talking about the nth root. It's talking about a root that is not yet defined. For example, it could be cube root, it could be square root, it could be any root. So in this case, the law states that we are going to have something like this, having our k raised to the power in a. That means the root, the nth root of a, because it is not that given. For example, when we have 2 raised to the power 1 over 2, it's telling us that the square root of 2. When we have 3 raised to the power 1 over 4, it's telling us that the fourth root of 3. So we have this. And that's how to apply that law of indices. Now let us move on to another law of indices. Now we have this law which states a raised to power m over n. A raised to power m over n. This is another law of indices. Here it states that we are going to have our nth root, we put our n, then a raised to power n. This is how to interpret this. That means we are going to have our nth root, then a inside the nth root raised to power m. So this is how to apply this. Let us take for example 4 raised to power 2 over 3. Here we will have the cube root of 4 square, which is the cube root of 16, and that is what this one is telling us, that when we have 4 raised to power 2 over 3, we have it to be the cube root of 16. Now let us move on to another law where we have a raised to power x equivalent to a raised to power y. When we have something like this, law of indices make us to understand that we eliminate a having similar number here. So therefore we are going to have our answer to be x equals y. Let's say for example, when we have 3 raised to power x to be equivalent to 3 raised to power 2. Here is telling us that we say 3 eliminate 3. So here we have our s to be equals 2. We make use of this every day in indices. Let us also take for example 2 raised to power 4 equivalent to 2 raised to power b. Here it says that 2 eliminate 2, so therefore 4 equals b, which is b equals 4. That is for the law of indices. Let us also deal with another law when we have m equals 2, m raised to power 2 equals 1 raised to power 2. Look at this. M raised to power 2 equals 1 raised to power 2. This law states that 2 is going to eliminate 2. That means the power is going to eliminate the power, so we have our m to be equals 1. For example, when we have b raised to power 2 equals 3 raised to power 2, it tells us that our 2 we eliminate 2, so we have our b to be equals 3. That means when we are solving a problem and we come across this, we can just apply this law of indices, then arrive at our final answer. Now let us put this right. If our b is equals 3, then let us substitute for b. That means b square equals what? 3 square. What's our b? 3. So 3 square equals 3 square, which is what? 9, equivalent to 9. You can see the law is applicable to solving a question like this. Now, that is all about the laws of indices. And let us now use this law in solving a question peculiar to them. Now, I have question number 1. Now, I have example number 1. We have 27 raised to power 1 over 3 times 9 raised to power 1 over 2, or divide by 100 raised to power 1 over 2 times 81 raised to power 1 over 4. Now, to solve this question, we are going to apply the laws of indices. Now, we have 27 raised to power 3. It is a particular law of indices, which is a raised to power 1 over n. And we state that we have this and a. So, this is quite similar to this, and we are going to apply them for all these questions we have here. So, it's simply telling us that the cube root of 27 multiplied by the square root of 9 divided by the square root of 100 times the fourth root of 81. So now let us break them down. The cube root of 27, that is 3. The square root of 9, that is 3. The square root of 100, that is 10. Times the fourth root of 81, that is 3. So in this case, 3 eliminates 3. So you have a final answer to be 3 over 10, or 0.3. And this is how to solve questions relating to laws of indices. Let us take example 2. Now, we have another example here. We have a number in fraction, and we are to use the law of indices to solve this question. The first thing we need to do is to convert this number to a fraction. And to convert a number to a fraction is to start from here. You have your decimal point, then take it to the last digit. So you have 1, 2, 3. So you have your 64 divide by, we took it how many times? 1, 2, 3. So it will be what? 1, 2, 3. Then we put 1. We have 1000. That means 64 divided by 1000 will give us 0.064 raised to the power 2 over 3. So here we are still applying the law of indices. So when we have question like this, here is telling us that the cube root of the square of 64 over 1000. So to simplify this, so we have the square of 64 over 1000. So we have here it becomes 64 times 64 divided by 1000 times 1000. So this is how we are going to solve this question. We fix in our answers here, then we find the cube root. We either express in fractions or we still leave it in sum. And that's how to apply the laws of sum to solving this question. So thank you for watching the Scholar online class. Make sure you like, share and subscribe to our channel.